Dear friends, in this video, we will cover the basic concepts of hypothesis. What is statistical hypothesis and one or two of its fundamentals we will discuss. This will lay the foundation for performing hypothesis testing in the context of decision making. Let's see. What is a statistical hypothesis? We all know hypothesis is an assumption or a conjecture. A statistical hypothesis is an assumption that you make about a population parameter. So you make the assumption in the form of a statement about the population parameter. It is called a statistical hypothesis. It may or may not be true. The manager has to ascertain the truth of the hypothesis, to what extent it is true, under what circumstances, how much can I rely, can I prove it, all these things we will have to understand in the context of statistical hypothesis. When you are formulating a problem that involves statistical hypothesis, you divide them into two parts: the null hypothesis and the alternative hypothesis. A null hypothesis is status quo, maintain the status quo. It is so formulated that its rejection leads to the desired conclusion, which is the alternative hypothesis. All decision makers and researchers generally want to prove the alternative hypothesis with the data and evidence, and they will feel very happy if the alternative hypothesis is proved. It is proved when the null hypothesis is rejected based on statistical evidence. That is the basic principle. There are circumstances where you may not be able to reject the null hypothesis for want of proper evidence. In that case, we say you accept the null hypothesis for want of evidence, and that is the basic principle we have to keep in mind. A hypothesis will have to be divided into two parts in the context of decision making: the null hypothesis, which is the status quo, and the alternative hypothesis, which is generally the matter of interest for all decision makers. And if the alternative hypothesis is proved, you are happy generally. That is the basic principle. So formulation is requiring practice and experience. We will see a couple of problems that we can solve and illustrate later. When you are making the formulation part of the null and the alternative hypothesis, no matter whatever may be your efforts, you cannot avoid two types of errors that you will commit. Rejecting the null hypothesis when it is true. This is called the states of nature. Either it is true or false. Rejecting the null hypothesis when it is true, that error is called the type 1 error. When you reject the null hypothesis when it is false, there is no error. Accept the null hypothesis when it is true, no error. Accept the null hypothesis when it is false is called the type 2 error. You see two symbols here within brackets, alpha and beta. Sometimes you use the term alpha risk and beta risk. and it is also associated with statistical significance. Let's see. So I'm just saying, what is alpha? Alpha is the probability of type 1 error. Committing the type 1 error probability is alpha. Beta is the probability of type 2 error. So type 1 error probability is alpha, type 2 error probability is beta. You are bound to commit these two errors. And you must keep in mind both alpha and beta cannot be minimized simultaneously. It's a trade-off. Whenever you minimize alpha, beta will increase, and minimize beta, alpha will increase. Therefore, it's a trade-off. Alpha is called the significance of the test. The probability of type 1 error is the level of significance which you use for statistical hypothesis. And beta is the type 2 error probability. 1 minus alpha is called the confidence level of the test. How confident are you in performing the test? And 1 minus beta is called the power of the test. How powerful the test is in differentiating the null hypothesis from the alternative hypothesis. This is the basic conceptual framework which we have to keep in mind and understand, and clarity will emerge when we actually solve a hypothesis problem in action, which we will see very soon. Thank you very much. Thanks a lot.